Welcome to David Alexander Maths Tuition. This is Chapter 10a, Angles in or for Quadrants. Okay, so let's take a quick look at the unit circles. So this is a circle that's got a radius of 1, centre 0, 0, so it's going through 0, 1, minus 1, 0, 0, minus 1, and 1, 0. Now, if I draw a radius, again, it will always be 1, and turn this into a triangle, and I call this theta, then what is the height of the triangle? Well, I'll call it x. Now we can use trigonometry here, so I can say that the sine of theta is x over 1, so therefore the sine of theta is x. So x is the sine of theta. So we need to be considering what happens to the height of the triangle as I slide this point in various directions. Now, if I slide it in an anti-clockwise direction, so this is 0 degrees, this is 90 degrees. So at the moment, I don't know how many degrees that is, but it's somewhere between 0 and 90, and this is the height of the triangle. Well, you can see that if I were to slide that point up to here, then the height of the triangle has increased. If the point was here, then this triangle would have no height at all. So that is why the sine of 0, sorry, not the sine of theta, the sine of 0 is 0, because this triangle would have no height. As I'm moving this point around to 90 degrees, when I get to 90 degrees, the triangle will have maximum height, and the height will be 1. So therefore, the sine of 90 is 1. So between 0 degrees and 90 degrees, we can see that the height of the triangle goes from no height at all up to the maximum height of 1. And when we think about our sine wave, the sine of 0 is 0, and then, well, let me just draw the full sine wave. So this is 90 degrees here, and we know that the maximum value is 1, and we also know that the minimum value is negative 1. So between 0 and 90 degrees, we can see that the height of this triangle is increasing, increasing, increasing until it gets to its maximum height of 1. Beyond 90 degrees, if I were to draw, okay, so this is the angle we would be measuring here. But we can see that as we get past 90 degrees, at 90 degrees it's got its maximum height of 1, but as we're moving the point further and further around, the height of the triangle will get less and less and less until it gets to this point here, when again it would have no height whatsoever. So again, we can show here that the sine of 180 is 0. And again, we can see that clearly on the sine curve. So from 0 to 90 degrees, the height of the triangle is increasing. From 90 to 180, it is decreasing. Now, once we get beyond 180 degrees, the height of the triangle, which, remember, there was no height whatsoever at 180 degrees, which is here. But as we go beyond 180 to 270, we are now having some height again to this triangle, but the height is negative height. So it's in the minuses here. And as we slide this around all the way to 270, the triangle, well, it won't be a triangle anymore, it will just be a straight line going down. So it would be, I suppose, if you can call it this, a triangle with no width, but a height of -1. So between 180 and 270, it's going from no width, no height, to maximum height. Well, it's maximum, which I suppose, which is the minimum. So it's going from no height whatsoever here to -1, which tallies with the sine graph here. And again, as we slide this point from 270 degrees back to 360 degrees, the height of the triangle will get less and less and less. Well, it will get less negative. The triangle will not look as tall, but remember, it has negative height. So I suppose its height is getting more positive because it's getting less negative, which explains why the curve is moving up in that direction. So let's take a look at the unit circle for cos. So again, here is my triangle. This is theta, radius 1. If I call this y, then I can say that the cos of theta is y over 1. So the cos of theta is y. So the width of the triangle is the cos of theta. So as I'm moving this point in this direction, this angle will increase, of course, but the cos of theta, which is the width of the triangle, decreases. So if the point is here, when the cos of 0, the width of the triangle is 1. So the cos of 0 is 1, except if I have 0 degrees, it's not really a triangle, it's more of a straight line. So when we're at this point here, the cos of theta is 1, and as I moving in this direction, theta is increasing, but the cos of theta is decreasing until I get to the cos of, this is 90 degrees, the cos of 90 degrees. Well, now I don't have a triangle, and again, I've just got a vertical line, so it has no width, so the cos of 90 is 0. As I move around in this direction, we are again, like if I move it around to this point here, then I am creating, so this is be the angle greater than 90 degrees. I have, well, this would be the width of the triangle, which is a negative value. So we can see that in this section here, between 0 and 90, cos is positive, the cos of theta is positive, but then between 90 and 180 degrees, it's negative. And again, if you think about your cos curve, which looks like so, between, okay, I've not drawn it brilliantly there, but between 0 and 90, it's positive and it decreases. Again, decreasing because as we're increasing the angle, the width of the triangle gets less, and it gets, the width of the triangle, I guess, is increasing, but as we're getting a negative value, it's getting more and more negative, which is why it's going right down to here where it gets its maximum value of -1 when we've got the cos of 180 degrees. So the cos of 180 degrees is 1, because if I move this point all the way right round over to here, again, I don't have a triangle, but I've just got a straight line, and remember, it's the horizontal part that is the cos of theta. It's the width of the triangle, or the base of the triangle. So we can see that it's got a width here of -1. Okay, so again, this is how we can use the unit circle to sort of try and understand why these curves work. So as we are moving this point around, the height of the triangle is increasing, but the width is decreasing until this point here. Between 90 and 180, the height is decreasing, but the width is increasing. Between 180 and 270, the width is decreasing and the height is increasing. And between 270 degrees and 360 degrees, the height is decreasing, but the width is increasing. Okay, so quickly to explain the cast diagram. So this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. Let's label them with the CAST. So starting in the bottom right, if you don't line these up in the right place, then the whole point of the cast diagram is missed. So CAST. So C stands for cos, S for sine, T for tan, and A stands for all. Okay, so what does this all mean? Well, in this quadrant here, we are going from 0 to 90 degrees. So what that means is between 0 and 90 degrees, all three functions are positive. So if we just take a quick look at the sine curve, between 0 and 90, we are getting a positive value. For cos, between 0 and 90 degrees, we're also getting a positive value. And let's just take a look at tan. So remember, these asymptotes are at 90. Between 0 and 90, tan is always positive. Now, in this quadrant here, so between 90 and 180 degrees, only sine is positive. So that is this part here of the sine curve is positive. The others will be negative. We can see here, this is 90, this is 180, cos is negative. And tan, if I draw in another tan curve, so this is 180 degrees here, and we are getting negative values for tan. Between 180 degrees and 270 degrees, tan is the only one that is positive. The sine is negative, cos is negative, but tan is positive. And between 270 and 360 degrees, cos is the only one that's positive. Again, we can see that is positive. We can see sine here is negative, and we'd have another bit of tan here, which would be negative. So this is the really important thing to remember. Between 0 and 90 degrees, all of them are positive, sine, cos, and tan. In this quadrant here, 90 to 180, sine is the only one that's positive. Between 180 and 270, tan is the only one that's positive. And between 270 and 360 degrees, cos is the only one that is positive. Okay, so let's look at working out what some values are. So the sine of 90 degrees. Okay, so remember that when we're looking at the unit circle, if this is a radius of 1, which it is, and this is theta, then, and we call this x, the sine of theta is x over 1. So it's the height that, it's the height of the triangle that is the sine of theta. So 90 degrees means I'm moving this point here all the way up to here. So the height of this triangle would now be 1. So then the sine of 90 is 1. If I move this point all the way round to 180 degrees, what is the height of the triangle now? Well, it will be 0. For the sine of negative 270, so if I measure the angles going in an anti-clockwise direction, so a negative angle would be the other way round. So minus 90 minus 180 minus 270, we can see the height of the triangle would be 1. Let's have a look at the cos of 90. Okay, so let's label this side y. So the cos of theta is going to be y over 1, so therefore the cos of theta equals y. So this is the cos of theta. So it's the width of the triangle that is the cos of theta. So what is the cos of 90? Well, if I move this point here all the way up to here, increasing the angle so it's 90 degrees, I've gone from maximum width to no width whatsoever. So therefore the cos of theta is 0. What about the cos of negative 180? So I need to go in a clockwise direction. So I'm starting off here, moving it around 180 degrees. Remember, it's the width that I'm looking at for the cos of theta, so that would be negative 1. Express the following in terms of trigonometric ratios of acute angles. Okay, so what we need to do here is we are measuring the angle, and we always measure it in an anti-clockwise direction. So let's just guess that that's about 150 degrees here. So what I need to do is I need to work out the angle that is created with the x-axis. So this angle here will therefore be 30 degrees. Now think back to cast, well, say think back, we've only been introduced to it recently. So you're C-A-S-T. So what I can say is, well, what I can do now is I can say that the sine of 150 is the same as the sine of 30. It's either the same as the positive sine of 30 or the negative sine of 30. Which is it? We just need to think about it's in the top left quadrant, that is the S quadrant, where sine is positive. So it's positive sine 30, not negative sine 30. So the sine of 150 is the same as the sine of 30. Okay, so we know that this is 180 degrees, so let's say this is 30 degrees here. If this is 180, if I take away 30, that would be 150, and we can see we're getting exactly the same value. So we can see from the graph as well that the sine of 150 is the same as sine 30. Well, you could see it properly if it was on Desmos. This is just a fairly feeble sketch. Okay, the sine of negative 10. So if it's a negative angle, I need to measure it clockwise. Okay, so this is me creating an angle with the horizontal of 10 degrees. So the sine of negative 10 degrees, we can say that is the sine of 10 degrees. But is it plus the sine of 10 degrees or minus the sine of 10 degrees? Well, let's do our cast diagram. C-A-S-T, the angle is created in the C quarter where only cos is positive, so sine is negative. So the sine of negative 10 equals the negative sine of positive 10. So again, you can type them into your calculator and check that out if you want. The sine of minus 210, so again it's a negative angle, so we're going around in an anti-clockwise, in a clockwise direction. So here is minus 180, so minus 210 will be all the way around to here. What is the angle that is generated between this line and the x-axis? Well, that will be 30 degrees. So I can say that the sine of minus 210 degrees is the same as the sine of 30, but is it positive sine 30 or negative sine 30? Well, let's have a look. C-A-S-T, the angle is in the S quadrant where sine is positive, so it's the positive sine of 30. Okay, here's another one, the cos of 290. So here I'm measuring, it's a positive angle, so I'm measuring it in an anti-clockwise direction. 180, 270, so 290. I need to measure the angle that has been created between our line and the horizontal axis, the x-axis. So we know that this is 20 degrees, so this is 70 degrees. So the cos of 290 is the same as the cos of 70, but is it plus cos 70 or minus cos 70? Let's do our cast diagram. C, A, S, T. This angle here is in the bottom right quadrant, which is the C quadrant, where cos is positive. So it's plus the cos of 70 and definitely not minus cos 70. So here we're working out the cos of minus 150. So we're measuring the angle in a clockwise direction. So 90 degrees, 180, so 150 will be in between. And if this is 150 degrees, then this is 30 degrees. Remember, we're interested in the angle that is created with the x-axis. So the cos of minus 150 is the same as the cos of 30. Now, if I label this CAST, this angle here is in the bottom left quadrant where tan is the only one that is positive, so therefore sine and cos are negative. So the cos of minus 150 is the same as the minus cos of 30. Tan of 420, well, if I do a full 360, I'm back to where I'm started, so that means I'll have another 60 degrees here. Again, it's the angle with the x-axis I'm interested in. So the tan of 420 is the same as the tan of 60, but is it plus tan 60 or minus tan 60? C, A, S, T. This 60 degree angle is in the top right quadrant where all sine, cos and tan are positive. So it's not minus tan of 60, it's plus tan 60. So the tan of 420 is the same as the tan of 60.